When responding to spills in shallow water environments, there's a number of factors we want to consider. Access is very important. We want to make sure that what we need to get into the location is available, but we want to take no further disturbance than necessary to enact our containment and recovery. Minimizing the impacts of our access is going to be very important to these environments we're working in. We want to consider the equipment and the manpower that's going to be necessary to work here. Utilizing low pressure, ground pressure equipment and walkways for our personnel is going to help us avoid damaging the root structures of the environment we're working in and keep the product on the water, not pushed down into our soils. Shallow water containment and recovery tactics are going to differ from conventional deployment means. Our depth of water really determines what equipment we can utilize for the sake of product recovery. When responding in a shallow water environment, we want to consider the safety of our responders. Soft soil conditions, open water, and wildlife all need to be addressed. Regulatory approvals need to be in place for vegetation disturbance, water diversion, and wildlife mitigation. In this video, we'll be discussing access and containment and recovery tactics for shallow water environments. A key oil spill preparedness strategy is to maintain pre-selected locations on rivers and streams for equipment deployment and equipment access. These are referred to as control points. You can find control points in your oil spill contingency manuals, and there are several important features which you should review. With control points, it's important to consider these factors. Good access, meaning that in good weather or bad weather, you can reach the locations that you need to deploy. Do they have landowner approvals? Has this been predetermined and pre-contacted to ensure access when necessary? Do we have room for equipment staging and possibly a suitable boat launch? Are they far enough downstream of the point of entry to allow a realistic response time? And always be aware that one control point is generally not enough. You will utilize several control points in a response. During the assessment phase of the spill, control points are often identified based on the conditions at the time of the incident, rather than sites that have been pre-identified and listed in an oil spill contingency manual. When responding to releases in sensitive aquatic environments, consideration should be given for low-impact tactics. Utilizing materials such as pallets or plywood will help keep responders up out of the vegetation, out of the contamination, while protecting the vital root structure of the surrounding vegetation. Safety considerations around these types of access materials should be taken into account. Slips, trips, and falls are very prevalent when working with materials such as pallets or plywood, so you may want to consider an item such as metal grating. It will increase traction for your responders. Mobilization of responders and equipment can still be achieved in a low-impact manner utilizing multi-wheeled ATVs and tub trailers. Portable vacuum systems also allow for recovery at these low-impact locations. Containment and recovery of spilled product into shallow water environments can generally be managed utilizing boom deployed into a V-pattern formation. In front of us we have two styles of boom. We have the creek boom. So what you'll see, the features of a creek boom, you've got small flotation, about 3 inches, and you've got about 4 inches of skirt. On the bottom, you've got about a 1/4 inch ballast chain. So this is designed for slower water and less depth. You'll see on the top here that there's no cable as well. These are still set up with an ASTM connector like all the boom that we have within the co-op, So this will connect to our other style of boom here, which is river boom. So river boom has larger flotation, 6 inches of flotation with a 6-inch skirt and a heavier chain on the bottom. Again, you'll see you've got the ASTM connectors, but the difference is on the top, we have a large cable here. This gives a lot of strength to the assembly. So what you'll have is this will work in faster water environments with much more pressure placed on it. The creek boom in front of me is set up with 5-foot folds, whereas our larger river boom here, you can see, is set up with 10-foot folds. The river boom overall is 50 feet in length. The creek boom can vary, but is generally 50 feet in length as well. Within WCSS's inventory, there's a standard 3 skimmer types: a Pedco skimmer, a brush skimmer, and a drum skimmer. When working in flowing water environments, a Pedco skimmer should be considered. Utilizing the suction of a pump, we control the amount of product that is recovered. What we have in front of us is our Pedco skimmer. We talked about it a little earlier on. These are designed for flowing water conditions. So what you've got is an off-balance drum that the more suction you place on it, the lower the drum sits and the more product it recovers. We're going to simulate that by turning on the pump. The Pedco skimmer now is recovering product. The more we adjust the ball valve over here, the more you'll see the drum drop and the more product we'll be taking in. So Everett's going to go ahead and open up that valve, and you'll see more water, more fluid being recovered. So now we're recovering more fluid. This is not optimal for recovery. So we want to choke that back and recover the least amount of fluid off the surface as possible. Due to the inefficiency of a Pedco skimmer, it's very important that you maintain the suction and constantly vary the throttle to ensure optimal recovery. What we have in front of us is our 2 most common types of pumps utilized on a recovery project. The one in front of me is just a water pump. Very simple to operate, very reliable. On the side here, you have your fuel on and off. You have a choke, and you also have your throttle control. So in combination with those and your on-off switch, you're able to operate that pump very, very simply. The pump creates suction by an impeller that's spinning inside of this housing. The water is drawn in here through your suction and discharged here. You'll notice on this end, for the sake of operating our Pedco skimmers, we've installed a ball valve system. This allows for fine control of how much flow is going through your pump. These pumps are reliable, simple, but they're not exactly intrinsically safe because they use metal components. You want to be aware of the volume of hydrocarbon you may potentially move through these. They work great with a Pedco skimmer, not something you want to move high volumes of hydrocarbon with. The second pump we have is an air-operated diaphragm pump. These can also be driven by a gasoline engine instead of air. This one here is an air-driven. So what you've got, your air source comes in here, goes through a regulator to allow you control the pump speed, and then the diaphragms inside go back and forth, creating suction. So your water gets sucked in the bottom and discharged out the top. These are much safer for using when pumping large volume of hydrocarbon because of the fact it's plastic components. You don't have that metal on metal potential contact, which could be an ignition source. This was an AquaGuard brush skimmer. The individual little blue bristles are oleophilic material designed to attract oil and repel water. These work very well in still water conditions where you have some debris that you need to separate. We're going to go ahead and install a scraper, which helps scrape the oil off and put it down into the recovery cavern. Now the brushes are picking up oil, rotating over, shedding the water, and the scraper bar here knocks the oil off and into the recovery reservoir. Two things you want to be very aware of utilizing the brush or drum skimmers. With the brush specifically, you have rotating equipment, and when we go to install this scraper, you have to be very careful of pinch points. So you want your fingers on the outsides as you employ that scraper. The other thing you always want to be aware of with any of your skimmers is the direction of rotation. From time to time, the fittings will get switched in the field. This is correct rotation for this brush skimmer. The other and the most efficient of our hydraulically driven skimmers is drum. This skimmer is again designed with an oleophilic drum, which will repel water and attract oil. It's much like the brush skimmer. The unit rotates, the oil is picked up and scraped off with these little scrapers on the front. The product is then falls down into the recovery trough and is pulled out by vacuum or pump to a recovery location. Due to the grooves in these drums, you increase your surface area, which makes this a very efficient skimmer, again, for still water environments. No matter which style of skimmer you're using, it's very important to manage the operation by controlling the speed. The faster the drum is spinning, the more water you may pick up, and the less effective the overall operation will be in terms of oil recovery. What we have here is a hydraulic power pack. It's a small diesel engine used to drive the hydraulic brush and drum skimmers. We're going to walk through the operation of it. A very important feature on the top here is what's called a decompression lever. You want to ensure that is down before starting it, otherwise you can have a very hard pull start. So once that's in place, you want to look at your throttle here. So we have stop, operate, start. We have a fuel on and off, and then we have a pull cord for starting. When you're connecting your hydraulic power pack to your skimmer, you've got two lines. You've got a supply and a return. The fittings are individually set up so that we can't get them backwards. They only fit one way. They can be a little bit of a struggle to get on, so you may need a second person to achieve this. Absorbents are a manual tactic utilized as a backup to containment boom. They generally come in two different styles: synthetic or organic. Synthetic absorbents, such as the boom and pads shown here, come in various formats. Some are designed specifically for recovering oil, others are more universal for recovering products such as glycol. You always want to make sure we're utilizing the right boom and the right pads for the product we're trying to recover. White and or potentially blue will generally signify an oil-only synthetic absorbent. Two examples of organic absorbents are here in front of me. I have kiln-dried peat moss, which works very well at recovering residual hydrocarbon, whether on land or water. Or a more passive tool, we have straw bales back here, which act as a filtering material, also to capture that residual hydrocarbon. Color change, or the amount of flotation, will change over time as the product becomes waterlogged. An absorbent boom such as this will need to be rotated to obtain maximum effectiveness. A product like peat needs to be applied and watch for a color change. That color change to darker material signifies the recovery of hydrocarbon. No matter which style we are utilizing at our spill recovery location, we want to always ensure that we work with our response contractors and regulators to obtain approvals prior to utilizing any of these absorbents. Before you begin recovering your spilled fluids at your location, you'll want to consider storage options. Portable means such as a small tank or drums may be considered for small volumes. But if you are working an ongoing operation, you may want to consider larger oil field style tanks to allow for long-term operation. Small means of containment, such as drums or porta tanks, are great for small volumes, but you need to consider the fact that you have a hydrocarbon in an open environment. The potential for flammable vapors can be a safety hazard. Ongoing recovery operations call for larger volumes of containment. When access is available, large vacuum trucks allow for not only the recovery of your spilled fluids, but the transportation to an approved disposal facility. When spilled product is on land or in shallow water environments, multiple considerations need to be made to ensure a successful response. The types of vegetation, soil, and weather can all play factors in a product's ability to migrate across land and into water, or downwards into your groundwater table. Blocking a culvert is a very valuable initial response tool. By minimizing the product migration in a ditch with simple tools that you may have in the back of your truck, you can minimize the footprint of your spill. So what we have here is just simply some sandbags, a piece of plywood that I had in the back of the pickup. If you have a shovel, then you can excavate some soil by hand to create a seal. Be aware with installing any kind of a culvert barrier, you want to do it on the upstream side of the culvert so that the product pushes into your barrier, not against your barrier. A pneumatic culvert plug is a great way of stopping product migration. The products are sized for the individual culvert you plan on using them in, so pre-planning is important with these products. You simply put them into the culvert, utilize a foot pump or some sort of air source, and fill them. They have a pressure relief valve on them, so they won't be overfilled if you're concerned about that. And then when you're ready to deflate them, there's a one-way valve built in for that purpose. It's also very important to remember, once this product is installed, you're going to need to maintain your water and product levels so that you don't overflow your ditch. Bladders and dams are useful tools for controlling and directing product. They're also very handy for redirecting clean water away from your spill site. These can also be used in conjunction with trenching for product control and clean water bypass. Potential materials for dams can be sandbags, soil, straw, water bladders, water gate dams, snow, or wood. Basically any materials you have available to you at your location at the given time. Bladders are synthetic rolls that can be filled with the water found at your location. You fill them and they will hold back the water or direct it away from your spill recovery site. Deployment of water gate dams is simple, as little as 2 people. You'll unroll the dam, face the open side to the flow, and drop the front into the water. At that point, it will start self-filling. From there, you move around to the back. You can open your control ports to control your flow, and you've got a portable dam. Be aware with water gates, you'll want to consider staking the front side to hold it into place, and that they can fill very quickly. So it's very important to open those ports probably before you even deploy. Installing inverted weirs are a very effective way of dealing with water that has hydrocarbon on surface. The premise behind an inverted weir is by tipping the pipe that's draining the water through, you'll maintain a flow of clean water from the bottom of your water source and maintain a hydrocarbon level up on top. So to build an inverted weir, you can utilize tools like sandbags, what we've got here. So you're going to want to prep your ground first. Ideally, we would remove our vegetation to create a good seal between the sandbags and the soil. From there, we would lay down a chunk of poly, so light plastic, just to help create a watertight seal, and then install your first layer of bags. As you're installing layers, you're going to find you may need to install one or even multiple pipes, depending on the flow that you have. So when you get to a height where you want to put a pipe in, you'll put a slit in the plastic, install your pipe on a tilt, and then continue to seal your sandbags around that. If you feel the need for extra piping or extra flow in the event of a weather change, then absolutely add more pipes at different heights, and then you can control varying flows. This is a small example here in front of you. We've got water coming out this side, which is being pulled from the bottom of the pond that we have now created with this dam. Be aware with inverted weirs that if your water is very shallow or if your pipes are too short, you may have a problem with what's called a vortex, where water is being sucked from the surface and will pull the hydrocarbon with it. If you see this happening on the upstream side of your weir, you want to adjust your pipes accordingly. A couple of points with inverted weirs. You want to always ensure that you utilize the natural terrain to your advantage. Look for bottlenecks or steep, short sections of bank where it will use a lower amount of sandbags to create your dam. Another point is upon the flow of your dam starting, you may want to consider erosion as an issue and line your discharge area to avoid scouring. Lastly, with inverted weirs, it's very important to remember these will not work well to maintain or hold back high salinity water. Produced water is much heavier, therefore it's already on the bottom and will travel straight through your inverted weir. So these are a hydrocarbon-based tactic. Filter materials such as this fence and straw bales can be utilized to filter out the residual hydrocarbon as well as protect sensitive areas. The fencing should be installed first so that the water flows through it, and you'll see that it's keyed in so it's below the surface of the water. On the back side of the fence, we've also installed a straw bale. These will work great for also capturing some residual hydrocarbon and act as a final filter. Be aware with your straw bales, you want to make sure that you stake them down because varying flows in the water could lift them and move them. Turner Valley Gate is a very handy tool for quick deployment in a stream situation. Much like containment boom, we can set it up in the same 30-degree or less angle and capture and or divert product to an area that we can recover it. You'll see how we have it laid out here, that we're directing product down the stream and into this V-shaped collection area right in front of me. This area will hold the product and allow us to do vacuum or hand recovery. A key feature that we want to always be aware when we're installing a Turner Valley Gate, the skirt material, which you see here, you want to hold back the surface product, but also allow water to still escape underneath. We're not trying to create a dam, we're just trying to create a barrier which will direct product to a suitable recovery location. The equipment is lightweight, can be carried by 1 or 2 people and deployed into small, shallow streams such as what we have here, and are a very portable tool. The Turner Valley Gate in its current configuration is designed for capturing product in this area here, but the versatility of these products with the folding wings allows us to also use it for deflection. By simply opening this wing up, we've now created a barrier which we can direct product to a more suitable recovery location. WCSS maintains an inventory of equipment to support your shallow water response efforts. For more information, check out our WCSS app, the Oil Spill Contingency Manual, our YouTube channel, and our website.